Okay, so let us start. See, all of you can see the slides.
Yes.
Okay, okay. See, yesterday we have discussed till this point that uh, for equilibrium to be satisfied, for general three-dimensional equilibrium, that means if you are analyzing a three-dimensional structure, in such case you will be requiring 6 equations, and because of the reason that solving the number of equations are more in case of a three-dimensional structure. Fake hai kya? So I accepted. Just a minute. You just remove him.
फेक क्यों रहेगा भाई? दिख नहीं रहा है मेरा नेम इसमें शो कर रहा है. फेक है, फेक करता है.
अभिषेक मिश्रा बोल रहे हैं. अंकित तुम है अभिषेक मिश्रा?
गुड मॉर्निंग सर.
ओके. अभिषेक मिश्रा.
हाँ भाई, अभिषेक मिश्रा हम नहीं है.
हाँ तो शांत रहो.
लेफ्ट हो गया.
Okay, leave it, forget. Let's start. So you see that for
गुड मॉर्निंग सर.
morning. So for making the things little bit easier, what generally we do, we change the structure from a three-dimensional and idealize it as a two-dimensional structure. Yesterday I have shown you how to idealize the structure as a two-dimensional structure, and if you idealize a structure as a two-dimensional structure, then number of equations of equilibrium reduces from 6 to 3. So you'll get 3 equations, that is sigma fx equal to 0, sigma fy equal to 0, and sigma mz equal to 0. Now you see, suppose I take a very simple structure. Let's say if I take a simple structure, this is a simple supported beam. You know, you have analyzed this kind of beams in your strength of material course. But you see, this is a simple supported beam. There is a UDL acting on it, and there is a point load. You notice that point load is acting at an angle. That means it is an inclined point load. It is not acting vertically on the structure. So see, for this kind of structure, when it is a simple supported structure, you see there is a pin support and there is a roller support. So when there is a pin support and there is a roller support, in that case, for this structure, how many reaction components may come? Because you see, this load is acting in the inclined direction. Because of this, there will be some horizontal reaction forces coming at this pin support. You see, there cannot be any horizontal forces coming in this roller support. Why? Because roller support only there can be vertical reaction, because on this direction it is free to move. So there will not be any reaction coming from the horizontal direction. So the only horizontal reaction will be coming on the pin support, and there will be a vertical reaction at the pin support, and there will be a vertical reaction at the roller support. So basically you observe from this problem, for a simple supported beam, you see your number of unknown components of reaction, that is F1, F2 and F3, these are the 3 unknown reaction components, and these 3 reaction components you should be able to solve using the 3 condition of equilibrium, that is summation of all the forces in the x direction equal to 0, summation of all the forces in the y direction equal to 0, and summation of all the moments about the z axis, that is on the other axis of x and y, is equal to 0. So you have 3 unknowns and you have 3 conditions of equilibrium through which you should be able to solve the problem. So thus, in such kind of problem where it is a simple supported beam of this kind, you notice that there is no need of other equations than equation of equilibrium, and thus we can tell these kind of structures as determinate structure. So what is determinate? Determinate structure means if you can, if you are able to solve a structure means you will have to solve the unknown reaction components which is coming because of the external loads and the internal loads also, internal moments and internal shears also. So if you know the external reactions coming into this, if you know the external reactions coming onto this simple supported onto these supports, then you should be able to find out what is the bending moment, what is the shear force in this structure very easily, right? So once you can solve this, once you can solve these three unknown reactions which can be easily obtained by these three equations of equilibrium, you can say this structure as determinate structure. Okay. So all the musics are done. Hello, Abhishek?
Yes,
Yes.
sir.
All the musics are done. Someone
No, sir, I think he left, sir.
Okay, anyway, forget.
Yes.
So you see these three equations can be solved using three unknown reactions. So thus we can say this structure as determinate structure. I think madam has also discussed you regarding this, Ankita madam. She is also telling you how to find out determinacy and other things. But the basic thing you should understand that a determinate structure is a structure for which you should be able to solve all the unknown reactions using the available equilibrium conditions or available equilibrium equations. Okay. Now this structure, when we are talking about, you see, this is typically a two-dimensional structure. This is not a three-dimensional structure. This is a two-dimensional structure. So in this case, you see, this two-dimensional structure, when we are talking about, obviously we will be having only three equations of equilibrium. So you need not to think about 6 equations of equilibrium and other things. Now coming to the next problem, see the next one. You see, next one is a very simple case, that is a cantilever beam. Now you see, in this cantilever beam also there is some UDL acting, which is vertically acting, and then there is some kind of point load acting. You see, this point load is again acting here at an inclined direction. So if it would have been acting in the vertical direction, in such case what would have been happening, that there will not be any horizontal reaction coming at this support, because of the vertical reaction, only vertical reaction you will be getting at this support. Whenever the load is acting at an inclined direction, at that time there will be two components of this load, one is in the horizontal direction and one is the vertical direction. So because of the horizontal component of the load, you are going to get an horizontal reaction, that is F1 will be coming at this support. And you see, this is a fixed support. So at the fixed support, you know, there may be three reactions coming, because fixed support is restrained to move in the vertical direction, it is restrained to move in the horizontal direction, as well as it is restrained for moving, restrained for any kind of rotation. So once the three directional movements are basically restricted, in such case you are going to get three reaction components, that is basically two force reaction components, that is F1 and F2 in the horizontal and vertical direction, and there will be a moment coming, that is MA. So moment about this point. So you see, in this case also, you see, there are three unknown reactions, and these three unknown reactions can be solved using these three equations of equilibrium, and thus this structure will be also taken as determinate structure. Now you see, whether this structure is stable, so you must understand the difference between equilibrium and stability. So you see, what is a stable structure? Is this structure is a stable structure? Is this structure is a stable structure? you need to understand the stability also. If a structure is satisfying the equilibrium condition, then also it may not be a stable structure. I will show you one example for that. Okay. So, if a structure is although satisfying the equilibrium condition, it may not be a stable structure, and if a structure is not stable, then actually what happens in such case, because of instability, either the structure may fail, that means it may break down, or it may start moving. So, a unstable structure, in such a case, it may happen that unstable structure will start moving, means it will become a mechanism. So, then in such case it will not remain a structure, or it may not remain a static structure. So, let us little bit understand more about equilibrium and determination. Now, you see what we have said. So, if the reaction forces can be determined, if you can determine the reaction forces solely from the equilibrium, if you can determine the reaction forces, which reaction forces? Reaction forces which are coming at the support or any other place for a structure, those reaction forces, if can be solely determined means only from the equation of equilibrium, if you can determine, in such case the structure will be termed as statically determinate structure. Is it clear? So, statically determinate structure basically can be solved using the equations of equilibrium. So, you please understand this, when it is a two-dimensional structure, then the structure will be statically determinate if there are three unknown reaction components, because you have three equations of equilibrium. On the other hand, if it is a three-dimensional structure, then in that case, if the unknown reaction components are 6, then also the structure will be called as determinate structure, because for a three-dimensional structure the available equations of equilibrium are not 3, they are 6. So, if the reaction components in a 3D structures, unknown reaction components in a 3D structure are 6, in that case also you should be able to solve the structure using equations of from the available equations of equilibrium, and in that case that three-dimensional structure will be also called as statically determinate structure. Clear? Now, next you see the number of unknown forces. If the number of unknown forces, okay, so unknown forces, it's not reaction, it's unknown forces. That means the forces, the unknown reactions, the unknown forces can be coming at the support as well as at the members. So, it may happen that structure looks to be determinate, because you can solve the unknown reaction components, but inside the structure some members are there, the forces inside those members cannot be solved using the equations of equilibrium. So, that is why whenever you will be defining indeterminate structure or indeterminacy, in that case you must remember this point, that number of unknown forces must be greater than the equilibrium equations, and if the number of unknown forces are more than the equilibrium equations, in such case the structure will be called as statically indeterminate structure. Okay. So, you understand from engineering mechanics how to draw the free body diagram of a structure. So, whenever you will be analyzing a structure, you can think from the global perspective, that means global coordinate system, you can analyze the structure, or you can also analyze the structure in the local coordinate system. That means global coordinate system means, suppose your structural assembly is directly in the x direction, y direction and z direction, then it is a global coordinate system. But if your structural assembly is not exactly along the x direction, exactly along the y direction, exactly along the z direction, in such case you may have to analyze the structure locally, and you have to change the local component of those members to the global component and then solve the structure. So, you can view a structure globally or locally through the free body diagrams. Now, you see, next is your this one. So, I was talking about stable structure. So, you see this diagram. Is this a stable structure? Anyone? The first one, what I am showing. Is this a stable structure or it is unstable? Can anyone tell? See, there are three reaction components coming.
Sir, 3 stable, sir.
It is a stable structure or unstable structure?
Stable, sir.
Forces are
Stable.
parallel, sir. Stable, sir.
Forces are parallel.
And
So you forgot engineering mechanics in that case. What I have said. So if there are parallel force system acting on a structure, okay, and there is no other forces coming, then the structure will not be a stable structure. See, from you just try to understand from very basic of it. See, there are 3 rollers on this, right? So rollers can have only 3 reactions. It cannot take any horizontal reaction, right? It cannot take any horizontal reaction. But you see, there is an inclined force acting over here. So if you resolve this inclined force in x direction and y direction, what is this x directional force is going to do to this beam member? What it will do? It will try to push this. Let's say if there is a horizontal component of this, then what it will do? Basically, you see, I will just show you using this. Just a minute. Suppose if this force component is resolved in 2 directions, let's say one is in the vertical direction like this and one is in the horizontal direction. One is resolved in the horizontal direction like this, then what will happen? Tell me. See, this because of this vertical reaction, this vertical load, vertical component of this load and this UDL, this can be restricted or resisted by this vertical reaction components at the roller. This F1, F2, F3 can resist this, it can resist this UDLs. However, can it resist this one? You tell me.
No, sir.
It cannot, because if there is a pin over here, then it could have been taking that horizontal reaction, right? But there is no pin, so what will happen? This roller, because of this, what will happen? This beam will start rolling, isn't it? This beam will start rolling because there will be a push coming to this beam, right? There will be a push coming to this beam like this, isn't it? There will be a push coming. So if there is a push, then this roller will start moving. Because of that movement, this roller will start moving, and then this roller will start moving. Then what will happen? The structure will start moving because of this load. So will this structure remain a stable structure in that case? Tell me.
No, sir.
No, sir.
So what will happen?
Unstable.
Yes, the structure will now become a mechanism. Are you getting? So you see, that is what is the point you should remember, that for any stable structure, whenever you are analyzing any statically determinate structure, you first need to remember whether the structure is stable or not. See, this is a statically determinate structure, looks to be a statically determinate structure, right? How many unknown reaction components are there? 3 unknown reaction components are there, and you have 3 equations of equilibrium to solve. So you can solve this structure, but no, you will not be able to solve this structure because this structure is not at all stable. because the horizontal load component acting on the structure will make this structure to become a mechanism. It will not remain a stable structure at all. It will not remain a static structure at all. So because of this instability, you will not be able to apply the equation of equilibrium to solve the unknown reaction components for this structure. Are you getting? So you must understand this point very clearly, because this structure, whatever may be the structure, the structure needs to be first stable. If the structure is not stable, you cannot analyze the structure at all from the structural analysis perspective. First is need to be stable. Okay, now you go to this point, next figure. So is this structure stable now? Is this structure stable? See, this structure will become stable if this support is replaced. This roller, if this roller is replaced with a pin support, you see this structure will remain, it will become a stable structure. Okay, suppose instead of this roller at A, if the roller is replaced by a pin support, then what will happen? The structure will become a stable structure. However, you will see that there will be then 4 reaction components coming, 1, 2, 3, 4. So 4 reaction components coming to the structure, and in that case structure is becoming stable, but you have 3 equations of equilibrium in your hand. So you cannot satisfy this condition. So the reaction forces can be determined solely from the equilibrium equation. So if for this structure, if you replace this roller support using a pin support, in that case you observe that you cannot solve this structure directly using the equations of equilibrium. So you have 4 equations, 4 unknown reaction components, and you have 3 equations of equilibrium. So you have 1 more reaction components available which cannot be solved or which cannot be found out using those 3 equations of equilibrium. In such case, you see this structure while replaced by a pin support over here will become a stable structure, but it will not remain a determinate structure. Is it clear? Okay. Now you come to the next point. So come to this one. So if you come to this structure, you see this is basically a cantilever beam. It looks to be a cantilever beam, right? So you see on this end, this is a fixed support, and then there is a beam. But you see this is not a pure cantilever. At the other end of the structure, it is being supported by a roller. Such kind of structures, do you know what is this kind of structure called?
Propped cantilever.
Yes. It is a propped cantilever, correct. So it is a propped cantilever structure. So when it is a propped cantilever structure, you see in a propped cantilever structure, when an inclined load is acting, a point load is acting inclined to the structure, and there is a UDL, you see what will happen? There will be again 4 unknown reaction components coming, 4 unknown reactions coming. So you see there are unknown reactions, 3 unknown reactions at this fixed support. Because why there are 3 unknown reactions coming at the fixed support, I have already explained multiple times, and there will be another 1 reaction component coming here. So you see whether this first thing you should identify whether this structure is a stable structure. Whether this structure is a stable structure. If this structure is not a stable structure, you cannot analyze it further. So obviously you see this structure is a stable structure, because this horizontal force, when it is coming over here, it cannot do anything because there is a restraint given over here. So this horizontal force, whatever is coming, it can be taken by a horizontal reaction at this support, at this fixed support. So basically this structure is a stable structure. So this is a propped cantilever, it is a stable structure, but you see the unknown reaction components in this case are 1, 2, 3 and 4. So 4 unknown reactions, and from the equilibrium equations, how many equations of equilibrium we have? As it is a two-dimensional structure, we have 3 equations of equilibrium available with us. So once we have 3 equations of equilibrium available with us and there are 4 unknown reactions, in that case this structure, although it is a stable structure, it becomes a indeterminate structure, which is indeterminate and stable, and the degree of indeterminacy is 1. That means the structure is indeterminate to degree 1. Is it clear? Okay. So next you see the determinacy and stability. So determinacy and stability. So see, determinacy and stability, these two things you need to understand hand in hand. Okay, because if a structure is not stable, whether it is determinate, indeterminate, doesn't matter. The first and foremost condition of any structural analysis is that the structure needs to be stable. So what is the condition of stability? So stability is basically to ensure the equilibrium of a structure or its member. It must satisfy the equations of equilibrium. So without satisfying equation of equilibrium, your structure cannot be stable. Next is, members must be properly held or constrained by the support. See, you take this example again. In this case, you see, this member AB is not properly held by this support. Because of this load, this member AB will start moving. So basically what will happen, the members are not properly held or constrained by their support in that case. But if you want to make your structure stable, then your members must be properly held or constrained by their supports. And the third point is, there is a unique set of values of reaction forces and internal forces. So there should be a unique set of values for reaction forces and internal forces. Unique set of values means you cannot say that here F1 force may come, F2 force may come, F3 force may come. It's not like that. At this roller, because of a particular loading arrangement, only F1 force will come. At this support only F2 force will come. At this support only F3 force will come. So there must be a unique set of values for reaction forces and internal forces. And when all these conditions are satisfying, then we can say that structure is a stable structure. Okay. So you see, this last slide we are discussing on this. See, determinacy and stability. You see, if you see this structure, this kind of structure, you see, when one beam member like this and one column member is held at A, you see, if you idealize this structure from here to here, you see, because of this inclined load, there will be a vertical reaction coming, there will be a moment coming. So fewer reactive forces than equation of equilibrium. So you see, you cannot if you try to hold this structure like this, because of this load, what will happen? Because at the point A, there will be slippage of the structure. So either the structure total assembly will move in this direction or the structure will move in this direction, depending on the inclination and the direction of the load. So see, the reactive components, the reactive forces, then equation of equilibrium. So what you are getting? You are getting lesser number of reactive forces. See, here you are getting one vertical reaction and one moment, but you are not getting any horizontal forces. So you are getting fewer reactive forces. So fewer reactive forces than equation of equilibrium. So when the reactive forces are lesser than the equation of equilibrium, in that case one of the equations of equilibrium will not be satisfied. in this structure, you see what is happening, this sigma fx equal to 0 will not be satisfied, and thus you see, although looks these structures to be stable, but no, as this number of reactive components of forces are less than the equation of equilibrium, in that case the structure as a whole or the members of the structure will be unstable. So I think with this we are concluding this introduction to structural analysis. So I tried to give you the concept behind what is structural analysis and how to analyze a structure, what are structural determinacy, indeterminacy, then how to idealize a structure, what are the different types of structure, what are the different types of forces come in a structure, all these things we have discussed. Okay. Now, if you have any questions, let us keep it open for any question answer session. So if you have any questions, please ask. Okay. Any question, or otherwise I will ask some question. Any questions you have?
Yes, sir.
Bolo. Tell.
Sir, that question, sir, that diagram, sir, F1 moment is acting. Can you show that page, sir?
Just a minute. Today's discussion.
Yes, yes, sir. Today's discussion. The structure was stable or not? That structure, sir.
Just a minute. This one. Yes. This
yes,
one.
So second question. Yes, the second one. I want to know that it is stable or not. So
second one. This one, right? This one.
Yes, sir.
See, this
Yes,
is
sir.
basically a propped cantilever structure. You have said, someone has said this is a propped cantilever, right? See, this structure is going to be stable structure, because you see what is happening. At this point there is a fixed support, at A there is a fixed support, and because of this fixed support, what is a fixed support? What does a fixed support does? You remember fixed support I have explained. What does a fixed support does? In the previous class we have explained it, right? Where? This one? No. Where was it? See, what are the things a fixed support can restrain? This is a fixed support, right?
yes, sir.
So what are the things a fixed
Reaction
support? One reaction in the
at
vertical
X,
direction,
reaction at 2y, and moment.
So that means it is restraining the movement in the horizontal direction of the structure. It is restraining the movement of the structure in the vertical direction, as well as it is restraining any rotation of the structure at that point, right? So you see, same thing is happening over here. You come to this propped cantilever. So you see, this is a fixed support. So this, because of this fixed support, this structure is not allowed to be moved in the horizontal direction. It will not be allowed to move in the vertical direction. It will not be allowed to rotate at point A, right? So this structure is perfectly held at this point, and on the other hand there is a roller support at this point. So there is some reaction coming at the roller support. So when an inclined load P is acting over here, you see, again if you just resolve this force again at the vertical direction, and then if you resolve the force in the horizontal direction, so what will happen? So see, this horizontal force which will be acting on the member, what it will try to do? It will try to push this member, right? So in this case also it was trying to push this member. So when it was trying to push this member, because there was no restraint provided over here, there was no holding over here, this structure was able to move. So that's why this structure was unstable. But in this case, you see, although this force is coming at this level, see, because of this restraint by this fixed support, this structure will not be allowed to move in any other direction. So it will be perfectly held at this position, right? So when it is perfectly held at this position, you see, this condition is getting satisfied, that members must be properly held or constrained by their support. So members are properly held and constrained by their support. So in this case, you see, this member AB is properly held by this fixed support, and it is also constrained by this fixed support as well as constrained by the support at B, which is a roller support. So this structure cannot move here and there. So it is not a mechanism. So it is a stable structure. Is it clear now?
Yes, sir. Thank you, sir.
Okay. Any question? Any more question? Anyone else? See, then I will ask some question. Let's see. See, Anuj. First Anuj. Unmute and answer. Okay? Anuj?
Yes, sir.
Yeah. Tell me, for a cable structure, what kind of forces you can expect in a member of a cable structure? What kind of forces you can expect in a cable structure? Cable member basically.
So tension force.
It will be always tension, or there may be compression also coming in a cable structure. Tell.
So tension.
Pardon? Only tension, or compression may also come? Hello? Tell me. Anuj, tell.
So tension.
Tension, yes. Only tension will come, right? Only tension will come. Okay, very good. Okay. Next, let us go to Anuj Kumar. This Anuj. Okay.
Yes,
okay.
sir.
Anuj, tell this. When you have a truss structure, okay, then can you tell me what kind of forces may come in a truss structure?
So tension and compression.
So it will be only tension and compression, or some other forces may also come?
So only tension and compression.
Only tension and compression. Very good. Only tension and compression. Okay. Ankit Singh, are you there? Hello. Ankit Singh, are you
Yes,
there?
sir.
Yes. You answer one question. Okay, try to answer. Okay. Suppose there is a truss structure. Okay. Suppose there is a truss structure, and the truss is supported by, at one end by a pin support and one end by a roller support. Whether the bending will come in any of the member in the truss structure, whether any bending will come in the member of truss structure or not?
Yes, sir, the bending will come
Bending will come.
at the end where the roller support is connected in the truss.
Will it be? See, that is why I am telling that concepts clearing is not happening. See, last semester also you have done. So what I have said, this figure. So see, this is a pin support, this is a pin support, or here you can have a roller support also. But where the loads will be acting in a truss member? In a truss member, the loads will be always acting at the joints, right? And the truss member will be the members of any truss. The members of any truss will be always subjected to tension and compression. There will not be any bending coming in a truss member. You must remember this. It's a very important assumption for a truss member. There cannot be any bending coming in a truss member. Are you getting, Ankit?
Yes, sir. Yes, sir. Yes, sir.
So there cannot be any bending, right? There cannot be any bending. Okay. Okay. So any other question you have?
No, sir.
Ayan?
Yes, sir.
Ayan, you tell me this diagram I have shown, this one. You remember this one? Can you see this diagram?
Yes.
Okay. So you tell me from this people, car, computer, furniture, whatever you are seeing in this diagram, are they live load or dead load?
Live load, sir.
Pardon?
Live load, sir.
Yes, live load. Correct. Correct. Absolutely correct. Okay. Okay. Thank you.
Okay, sir.
Next, Akib Malik. Akib, are you there?
Yes, sir.
Yes. You tell. Same question I am asking. This on this structure. Can you see there is a wind acting, there is a snow acting, and there is a water tank also here. So you tell me, this water tank, is it a dead load or live load or something other? There is a water tank on the structure. So whether this water tank will be considered as a dead load or live load or seismic kind of load, which kind of load it will be, this water tank load? Akib,
Yes, sir.
bolo.
A dead load, sir.
It will be dead load. See, you should go through the presentation as well as the lectures. Okay, otherwise, see, it will be very difficult to understand other later part. Buddhadev, you tell. Buddhadev.
Live load, sir.
Live load, yes, because water tank, any kind of moving kind of load, these loads are always moving kind of load, because a water tank will be sometime half filled, sometime full filled, sometime it will be empty, so there will be change of the load. So as I have explained you, only the member loads, that is the load from the beam, load from the column, load from the slabs, those are the kind of the load which will be only considered as dead loads. All other loads, like the loads from the people, load from computer, load from furniture, all these things will be considered as live load. So can anyone tell? Okay, let me see. Chandidas, are you there? Chandidas Banerjee, are you there? Jishu.
Yes, sir. Yes, sir.
Yes. Tell me, this different loads you can see in this structure: snow load, water load, wind load, this load, that load, different types of load. Can you tell me what is the Indian standard code where these loads are specified? I have mentioned you. You remember the Indian standard code?
IS 456.
No, IS 456 gives you some details about this live load, dead load, how it to be taken, right? But where it is defined? It is defined in, anyone can say?
SP 16.
875.
825.
800? 825 or 75?
75.
75, yes.
75.
75, yes. 875, Indian Standard Code 875. There are different parts of it. In 875 part 1,
part 2,
part
part
2,
3,
yes,
part 5.
yes. So at different parts, different loads are mentioned. Like maybe in 875 part 1, there will be definition of dead loads. So how do you calculate the dead loads? Those are defined. For any live loads, the definitions are given in 875 part 2. Snow load definitions are given, wind load definitions are given. All these are given in different parts of 875. You must remember it. See, Indian Standard Code IS 456 is not the code which defines the different loads. It is basically it basically defines the reinforced concrete design of structure. Okay, how to design a reinforced concrete structure, that is being explained in IS 456. And while designing a reinforced concrete structure, also you will have to consider the dead load, live load, wind load, earthquake load. So all those loads, how they need to be considered and how they need to be combined, those kind of definitions are given in IS 456, but it does not specify how much dead load, how much live load you will have to consider. If you want to find out those things, you will have to refer Indian Standard Code IS 875. Okay. Okay. So let us see anyone. Liton Bormon, are you attending classes regularly? Liton Bormon, or are you sleeping? Liton Bormon, can you hear me? Hello. See, I think he has just entered and left. Okay, so if you have any more questions, can you ask? Kollan Mandal, are you there?
Yes, sir.
Kollan, you try to answer one question. See, I have told you about structural analysis. In this 3 or 4 classes, I tried to explain what is structural analysis and basics and introduction of structural analysis. Now, can you explain me what are the things you need to find out in any structural analysis problem? What are the basic 3 things or basic 2 things, 3 things, whatever it may be? What are the 3 things you need to find out in any structural analysis problem? See, I have given a quiz on this also. Tell. Anyone?
Reaction forces, internal forces, and deformations.
Yes, absolutely correct. So reaction forces. So first thing you'll have to find out what are the reaction forces. Then you'll have to find out the internal forces, right? So can anyone tell what are the internal forces? Can anyone tell what are the internal forces? Anyone? See, he has said that internal forces.
No.
So reaction forces, you know. What are the internal forces of a structure?
Shear force, bending moment.
Yes, absolutely correct. So internal forces are shear force, bending moments. And how do you calculate deformations? Have you learned any method for calculation of deformations in structure in your strength of material course?
Macaulay's method, the double integration method.
Yes, absolutely correct. Macaulay's method, double integration method. You will be
Moment
learning
area method.
moment area method. Yes, you will be learning more about these deformation calculations in this semester of structural analysis. Okay. So absolutely correct answer you have given. Reaction, internal forces, and deformations we need to find out. Okay. Very good. So more attendance are coming. Smriti, Anand, Anuj Kumar. Okay. So see, if you have any other questions, you can ask from today's class or the last 3 class, whatever we have discussed. Principle of superpositions, all of you have understood clearly? Principle of superposition.
Yes, sir.
Yes, sir.
Can anyone explain? Who will explain principle of superposition? Who will explain? Praman Yogi,
Yes, sir.
can you explain what is principle of superposition?
Sir, when in a structure, if
Hmm.
several forces are acting,
Hmm.
then the total force is equals to the summation of all the forces which are acting on that structure.
Yes, it's not exactly all the forces acting, you should not say. Okay, obviously total forces will be always will be total forces, whatever will be acting will be summation of all force. You should say deformation or the reactions or the internal forces being created by the external forces. Okay, so sum of the individual those things created by individual forces will be equal to sum of all the forces. Okay, so you should not say sum of all the forces equal to sum of all the forces. Obviously sum of all the forces will be equal to always sum of all the forces. Okay, so you must specify what are which sums, the total displacement or internal loadings or stress. That means whatever we are analyzing in a structural analysis process, the deformation, reactions and whatever deformation, reaction and internal forces. So total displacements and internal loadings or stress, whichever we will be having at a point in a structure, subjected to several external loads. So when the several external loads are acting on the structure, that can be determined. How you can determine it? You can add it together, the displacements or the internal loading stresses caused by each of the external loads acting separately. So it's not that, see what you are saying, you are saying this load and this load will be, if we sum it up, it will be equal to total load. No, that is not the case. The deformation because of this load, which is actually this much y1x, which is actually y1x, and the deformation because of this load which is actually y2x at this point. So if you sum it up y1x and y2x at a particular point, you are going to get the total deformation because of these two loads. So individual deformations by individual loads acting on a structure, if you are summing it up, those individual deformations, then that sum will be always equal to the deformations created by all the external loads acting together on the structure, and that is actually principle of superposition. Is it clear now, Prema?
Yes, sir.
Okay, so you should be very clear about this. Okay. So I think let us complete this part today. If you have any more question, you have another 2-3 minutes, you can ask me, or otherwise we will stop this session today. And in the next class I have already told you, we'll start with some concepts of influence line. And influence line concept is first when you will start, it will look to be similar to the concept of bending moment and shear force. So I will request you just refresh your knowledge of bending moment and shear force, whatever I taught you in the last semester. Okay, so bending moment, shear force, how to find out the bending moment and shear force, that you should be very clear about. Then only you will be able to understand influence line, because at that point I cannot clear your doubts on bending moment and shear force on a simple structure. So if you are clear on bending moment and shear force, you will be able to understand influence line, which initially you will be thinking that it is just like bending moment and shear force, but no, it is not bending moment and shear force exactly. It is the bending moment and shear force shear force only at a particular point in a structure because of the different position of load acting in a structure. So we will discuss it in detail in the next class, but before we start with influence line in the next week, I advise you to just refresh again your knowledge and whatever I have told you regarding the bending moment and shear force in the last semester, because bending moment and shear force again and again will be coming when we will be discussing about influence line diagram. Okay, so let us stop here today. Thank you very much. Okay,
Thank you, sir.
so I have downloaded this, just a minute, download. There is a Google form is, see, always you, can you come with your this thing, roll number here, can you join the meeting with your roll number over here? Is it possible?
Yes. Yes, sir. Yes.
Is it possible? See,
Yes,
if it is there na, then I can directly collect the attendance like this. See, today 27 member including me has attended. Can you see this in the screen? Can you see this?
Yes, sir.
See,
Yes,
this
sir.
Anuj Kumar, Ayan Chakravarti, Buddhadev Sadra, Isita Godai, these all of you have attended today's session. Okay, so I can directly collect it in that case. So if you
Sir,
join,
though what?
tell me.
Sir, Anuj 2 times.
Anuj 2
Nahi.
times obviously will be there, na? 2 times.
No,
Anuj,
sir.
2 times Anuj is not there because this is not finding the, it is finding unique name, na? So Anuj Kumar one seat has got, and then second time it is not getting. Okay. So if you can join this meeting with this roll numbers over here, then directly it can be collected, your attendance, while you are
Okay, sir.
attending the Google Meet. Okay. So Abhishek, Vishwakarma has left.
Left, sir.
Yes, sir. Yes, left.
Okay. So please, Anuj, you tell Vishwakarma, if everyone can join this thing with the roll number, na, then automatically
Yes.
I can collect the attendance also here. Okay.
Okay, sir.
Okay. There is a Google Meet attendance collector through which we can collect, through which we should be able to collect. Okay. Thank you.
Okay, sir.
Thank you.
Thank you, sir.
Thank you very much. We'll stop here. Huh?